Hi, welcome to Module 5 of the Up to Extension 1 Bridging course offered by the University of Sydney. In this module, we will deal with polynomials and rational functions. So you might be wondering, what is a polynomial? Well, let's have a look at some examples. These four expressions are each an example of a polynomial in one variable. What's a variable, you ask? Well, in these examples, the symbols x, y, z, and t are the variables. This just means that you can replace each of the x, y, z, or t with some fixed number and then evaluate the polynomial to get some other number. The fact that polynomials can take some number and transform it into some other number makes them a particular instance of a function. For example, we can put the number 5 into the polynomial q by replacing all the variables, or equivalently y's in this case, with the number 5 to get the output 287. That is, the function q takes the number 5 and transforms it into the number 287. Additionally, you can have multivariate polynomials, which are polynomials in two or more variables. Here are some examples of multivariate polynomials. We say that the first two expressions are polynomials in 3 variables, and that the third and fourth expressions are polynomials in 4 and 5 variables, respectively. If you are unsure about why this is the case, then pause the video and try to figure it out for yourself. Now, why should we care about polynomials? Well, one of the biggest uses of polynomials is that they are able to describe all sorts of curves. For example, the trajectory of a ball under the influence of gravity may be described by a polynomial. As another example, polynomials may be fitted to points of data which may be used to establish correlation in statistics, or to observe trends in finance, or even to analyze internet fads. As you will see in the next 3 videos in this module, polynomials in one variable can be viewed graphically as curves, which may be able to model all sorts of phenomena observed in the world around us. You will also see that we can combine polynomials through multiplication, and what's more, we can even combine certain types of polynomials through division. If one polynomial can divide another, then the result is a ratio of polynomials, which is known as a rational function. This is the subject of the 3rd video in this module. But let's not get ahead of ourselves. In the first video of this module, Clinton will define what a polynomial actually is, as well as some related concepts. And by the end of the first video, you should know how and when you can actually divide polynomials. In the second video, we'll further explore division of polynomials as we dive into a major result known as the remainder theorem. And of course, as I mentioned before, in the 3rd and final video of this module, we'll learn about rational functions and tie together the concepts that were explained throughout the module. I hope you enjoy these videos. And remember, mathematics requires you to engage in active thought. It is very difficult to synthesize mathematics passively, so please think about the content after you've watched the videos, in addition to practicing the exercises.